Hello everyone, welcome to Kanitha Maths channel. In today's video, we will be discussing CBSE Class 10 Maths Chapter 3, Section 3.3 and 3.4. Section 3.3 Algebraic Methods of Solving a Pair of Linear Equations. So in this section, we are going to discuss another method for solving pair of linear equation known as algebraic methods. So compared to the graphical method, this method will give us the solution in a precise way. Sometimes in graphical method, we feel difficulty when we have the solution for the linear equations to be non-integral. Coordinates like irrational numbers or fractional forms. It is very difficult for us to identify the solutions or plot the graph. So algebraic methods will be very convenient for us to identify the solution. So in this section, we are going to discuss two methods of algebraic methods known as substitution method and elimination method. In the substitution method, what we are going to do is we will take one equation from the pair of linear equations and we will represent that equation such that the variable say x will be represented in terms of the other variable say y. Now this x value will be substituted in the second equation so that we will be resulted with the equation which will have only one variable. By solving that, you will get the value of y, and again you can substitute in the first equation or second equation and you will get the x value. So this type of substituting the value will lead to the idea known as substitution method, right? So let us discuss the example 4, solving the following pair of equations by substitution method. 7x minus 15y equal to 2, x plus 2y equal to 3. Here you can see that they have taken the second equation since the coefficients are small, and they have rewritten the variable x as 3 minus 2y. And if you substitute this x value in the first equation, that is 7 into 3 minus 2y minus 15y equal to 2, and if you simplify this, you will get the value of y to be 19 by 29, and if you substitute this in the third equation, you will get the value of x to be 49 by 29. Thus we have obtained the x and y value. So in this method, you have to choose the equation for rearranging such that it will have the simple coefficients. So among the two equations, which one is simple, you can take that. Clear? And similar to that of the graphical method, you can also substitute the values or the solution what you have obtained in both the equations and you can verify it, right? So here they have given the steps involved in the substitution method. Step 1, find the value of one variable, say y, in terms of the other variable, that is x, from either equation, whichever is convenient. So you can choose the simplest equation among the two. Step 2, substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. Sometimes, as in example 9 and 10 below, you can get statements with no variable. If this statement is true, you can conclude that the pair of linear equations has infinitely many solutions. If the statement is false, then the pair of linear equation is inconsistent. So in the upcoming examples, we will discuss this elaborately. Step 3, substitute the values of x or y obtained in step 2 in the equation used in step 1 to obtain the value of the other variable, right? Remark, we have substituted the value of one variable by expressing it in terms of the other variable to solve the pair of linear equations. That is why the method is known as substitution method. Clear? Next, example 5. Solve the following question. After tells his daughter, 7 years ago I was 7 times as old as you were then. Also, 3 years from now I shall be 3 times as old as you will be. Represent this situation algebraically and graphically by the method of substitution. So now we have to identify the um, age of Aftab and his daughter. So first we have to form the equation for this situation, that is linear algebraic equation we have to form, right? So the conditions what given are 7 years ago it was 7 times as old as you went there. So Aftab was 7 times as old as his daughter 7 years ago, right? And also he added that 3 years from now he will be 3 times as old as her daughter. Now we have to form the pair of linear equations and we have to identify their ages, right? So here they have taken S and T to be the ages in years of Aftab and his daughter. The current age of Aftab is S and his daughter is T. And from the situation what given above, we can form the equations such that 7 years ago, so uh, 7 years ago his age will be S minus 7 as well as his daughter's age will also be T minus 7. And what he said is 7 years ago his age was 7 times as old as his daughter. So S minus 7 equal to 7 into T minus 7. So when you simplify this you will get S minus 70 plus 42 equal to 0, and 3 years later his age will be S plus 3 and his daughter's will be T plus 3. So what he said is his age after 3 years will be 3 times as old as his daughter. So S plus 3 equal to 3 into T plus 3. So when you simplify you will be resulted with S minus 3T equal to 6. When you simplify these two equations such that you have to take the simplest equation. So here the simple one is S minus 3T equal to 6. Now if you rewrite this equation such that S equal to 3T plus 6. Now we have represented S in terms of T. And if you substitute this S value in the first equation, wherever S comes you have to replace it with 3T plus 6. And if you now we are resulted with one equation with one variable. So it is easy for us to solve. So after simplification we are resulted with T equal to 12. Now if you substitute this T equal to 12 in the new equation what we have arrived, that is S equal to 3T plus 6, you can easily get the value of S to be 42. So thus we have estimated the current age of Aftab to be 42 and his daughter is 12. Clear? And if you substitute these values in both the equations, you will get the equations to be satisfied, and we can also check this. So we have to write the equations corresponding to the data given to us. So the two equations are S minus 7t plus 42 equal to 0 and S minus 3t equal to 6. The solution what we have obtained is 42, 12. So let us substitute it. So this is the S value and this is the T value. So let me substitute in the first equation. So 42 minus 7 into 12 plus 42. So if you substitute, if you simplify this, you will get 42 minus 84 plus 42. You will get the left hand and right hand side to be equal. So thus we have verified the first one, and the second one if you substitute you will get 3 into 12, that is 36, and if you simplify this you will get the answer to be, we will get 6 equal to 6. So thus we have verified the solution. Next, moving on to the example 6. In a shop, the cost of 2 pencils and 3 erasers is 9 rupees and the cost of 4 pencils and 6 erasers is 18 rupees. Find the cost of each pencil and each eraser. So a similar problem we have discussed in the previous section using graphical method. Now we are going to solve this problem using algebraic method. Fine. So now let us take the cost of each pencil to be X and the cost of each eraser to be Y. And from the above given conditions, what we know is cost of 2 pencils and 3 erasers is 9. So 2x plus 3y equal to 9 and 4x plus 6y equal to 18. So now we are resulted with 2 equations. Now let us take the simplest one and we can rearrange the equation. So here they have taken 2x plus 3y equal to 9 and they have rewritten the equation such that x equal to 9 minus 3y by 2. When you substitute this x value in the second equation, we will get 18 equal to 18, which means the y variable completely get cancelled. So we don't get the y value here. So from this what we could conclude is this y can have any value. Since y can have infinitely many value, the corresponding x will also have infinitely many values. So thus what we can conclude from this is, in case if you can't identify the value of one variable, you will be resulted with infinitely many solutions. So for this case, we will have infinitely many solutions. We cannot find the unique cost of the pencil and erasers. So please note down this example, it's very important. Example 7, two rails are represented by the equations x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Will the rails cross each other? So basically what they are trying to ask is if there is any point of intersection. They cross each other means there should be some point of intersection. So we have to identify. So what we are going to do is we are going to apply the method of substitution. So let us take the first equation and rewriting this as x equal to 4 minus 2y and substituting the second equation. And if you simplify, again the y variable is getting eliminated, and now in this case they are getting x minus 12 equal to 0, which means minus 4 equal to 0, which is not at all true. In the previous example, we are getting the left and right hand side value to be equal. Though we are not able to identify the y value, the statement what we have resulted is true. But here, the statement what we have resulted is false. So if the statement is true, we will have infinitely many solutions, and if the statement is false, then we will have no solution. So what we could conclude is there will be no solution for the pair of linear equations, which implies the two rails will not cross each other. So there will be no point of intersection. Clear? Moving on to the exercise 3.2. Question number 1. Solve the following pair of linear equations by the substitution method. So here they have given a pair of equations and now we have to use method of substitution to solve this. It's exercise 3.2. Question number 1. First subdivision, x plus y equal to 14, x minus y equal to 4. So we can easily solve this. Let us take the first equation and I am rewriting this as x equal to 14 minus y. We name it as the equation 3, and if you substitute this in the second equation, you will get 14 minus y minus y, we will get 2y equal to 4. So if you simplify this, you will get 2y equal to 10, y equal to 5, right? So if you substitute this y value in the equation number 3, you will get x equal to 14 minus 5, that is 9. So thus we have determined the value of x and y to be 9 and 5. Clear? Then second one, s minus t equal to 3, s by 3 plus t by 2 equal to 6. The simplest one is the first one. So let me rewrite this as s equal to 3 plus t, name it as 3. So if you substitute in the second equation, you will get 3 plus t by 3 plus t by 2 equal to 6. So in order to simplify this, let me take the LCM. So you will get 6 plus 2t plus 3t equal to 6 6 are 36, right? So 6 plus 5t equal to 36. So 5t equal to 30, t equal to 6. So if you substitute this t value in the third equation, you will get s equal to 6 plus 3, that is 9. Fine. So thus we have determined the value of s to be 9 and t to be 6. Third one, 3x minus y equal to 3, 9x minus 3y equal to 9. So let me take the first equation and rewrite it. So you will get x equal to 3 plus y, or you can simply take y. It's very easy. Still you can take y, nothing wrong in that. So you will get the value of x to be 3 plus y by 3. And when you substitute this in the second equation, you will get 9 and 3 will get cancelled. So 3 into 3 plus y minus 3y equal to 9. If you simplify this further, you will get 9 plus 3y minus 3y equal to 9. So 3y and 3y will get cancelled and you will get 9 equal to 9. Right? So 9 equal to 9 is the statement which is true, but still we cannot find the value of y. So what we could conclude is this system of equations will have infinitely many solutions. Right? So any equation satisfying the any x and y values satisfying these two equations will be such that they will be infinitely many. Clear? Question number 4. 0.2x plus 3y equal to 1.3. 0.4x plus 0.5y equal to 2.3. So among the two equations, let us take the first one. So if you rewrite this, you will get the x value to be 1.3 minus 0.3y whole divided by 0.2. So if you substitute this in the second equation, you will get 0.4 into 1.3 minus 0.3y whole divided by 0.2 plus 0.5y equal to 2.3. So if you simplify this, you will get, this is 2 times, right? So 2 into 1.3, so 2.6 minus 0.6y plus 0.5y equal to 2.3. So if you simplify this, you will get 2.6 minus 0.1y equal to 2.3. So minus 0. We can rewrite it as 0.1y equal to 2.6 minus 2.3, that is 0.3. So y equal to 3. Fine. So if you substitute this y value in the third equation, what we have obtained, x equal to 1.3 minus 0.3 into 3 is 0.9 whole divided by 0.2. So if you simplify this, you will get the answer as 0.4 by 0.2, which is equal to 2. So x equal to 2 and y equal to 3 is the answer. Fine. Next, question number 5. Root 2x plus root 3y equal to 0. Root 3x minus root 8y equal to 0. So if you rewrite the first equation, you will get x equal to minus root 3 by root 2y. If you substitute the third equation in the second equation, you will get root 3 into minus root 3 by root 2y minus root 8y equal to 0. If you simplify this further, you will get minus 3 by root 2y minus root 8y equal to 0. If you take LCM, you will get minus 3y minus root 8 into root 2 root 16, but square root of 16 is 4, so 4y equal to 0. So if you simplify this further, you will get minus 7 by root 2 y equal to 0. So this implies y equal to 0. Y equal to 0, if you substitute in the third equation, you will get x equal to 0. So thus the value of both x and y will be equal to 0. Next, problem number 6. 3x by 2 minus 5y by 3 equal to minus 2. The second one is x by 3 plus y by 2 equal to 13 by 6. Now we are going to rewrite any one of the two equations. Let me take the second one. So if I rewrite that, I should get either x equal to y or y equal to in terms of x. But we have the denominator. So in order to simplify that, first let me take the LCM. So if I take the LCM for the second equation, I will get 2x plus 3y whole divided by 6, which is equal to 13 by 6. So this can be again rewritten as 2x plus 3y equal to 13. Right? If you rewrite this, you will be resulted with x equal to 13 minus 3y whole divided by 2. Right? So if you substitute this x value in the first equation, you will get 3 by 2 into 13 minus 3y whole divided by 2 into a minus 5y by 3 equal to minus 2. So now if you simplify this, you will get 39 minus 9y whole divided by 4 minus 5y by 3 equal to minus 2. Now if you take LCM, you will get 12 in the denominator, and in the numerator you will get 117 minus 27y minus 20y equal to minus 2. So if you simplify this, you will get 117 minus 47y, which is equal to minus 24, and we will get 47y equal to 117 plus 24, which is equal to 141. So if you simplify this further, you will get 141 by 47 equal to 3. So if you substitute this y value in the equation 3, you will get x equal to 13 minus 9, that is 4 by 2 equal to 2. So thus we have determined the value of x and y to be 2 and 3. Problem number 2. Solve 2x plus 3y equal to 11 and 2x minus 4y equal to minus 24, and hence find the value of m for which y equal to mx plus 3. So now we have to solve these two equations, and by using that x and y value, we have to substitute in the third equation what they have given, and we have to identify the value of m. Clear? So by using method of substitution, we are going to solve these two equations first. So problem number 2, the two equations are 2x plus 3y equal to 11, and the second one is 2x minus 4y equal to minus 24. Right? So let me rewrite the first equation as x equal to 11 minus 3y whole divided by 2. If you substitute this in the second equation, you will get 2 into x. So 2 and 2 will get cancelled. So 11 minus 3y minus 4y. So that is minus 7y equal to minus 24. If you simplify this further, you will get 7y equal to 11 plus 24, that is 35. So y equal to 5. So if you substitute this in the third equation, you will get x equal to 11 minus 3 5s are 15. So 11 minus 15 is minus 4 by 2, which is equal to minus 2. So thus we have determined the x and y value. Now what we have to do is we have to substitute this x and y value in the equation y equal to mx plus 3. Y equal to 5 and x equal to minus 2. So minus 2m plus 3. So if you simplify this, you will get 2m equal to 3 minus 5 is minus 2. So m equal to minus 1. Clear? So we have determined the value of m to be minus 1. Next. Problem number 3. Form the pair of linear equations for the following problems and find their solution by substitution method. The difference between two numbers is 26 and one number is 3 times the other. Find them. So here they have considered two numbers. Let us take it as x and y, and they have given the difference between two numbers is 26. Fine. And now the second condition what they have given is one number is 3 times the other. So simply they have given one number is 3 times the other. So we can take any number. Okay, randomly we can pick that one number is 3 times the other. So let me take x equal to 3 times the other y. Now we have to solve these two. So since the second equation is already in the simplest form, now we can substitute this second in the first equation. So you will get 3y minus y, that is 2y equal to 26, which implies y equal to 13. So this gives x equal to 3 into 13, that is 39. So we have determined the two numbers to be 39 and 13. Okay. Now you can check the difference between the two numbers is 26 and one number is 3 times the other number. Clear? And moving on to the second problem. The larger of two supplementary angles exceeds the smaller by 18 degrees. Clear? So we have two supplementary angles, and what they have given is the larger one exceeds the other smaller one by 18 degrees. Now we have to find the two supplementary angles. Clear? So let us take the two supplementary angles to be x and y, and what we know is that the larger one will exit the smaller one by 18 degrees. So let x equal to y plus 18. Okay. And we need one more equation. Since the two angles are given to be supplementary angles, their sum should be equal to 180 degree. Clear? So if you substitute the first equation in the second one, you will get y plus 18 plus y, that is 2y plus 18. So 180 minus 18. So if you simplify this, you will get the answer to be 162, and if you simplify this, you will get the value of y to be 81. And if you substitute this in the first equation, you will get x equal to 81 plus 18 will give you the answer as 99 degree. Clear? Third one. The coach of a cricket team buys 7 bats and 6 balls for 3,800 rupees. Later, she buys 3 bats and 5 balls for 1,750. Find the cost of each bat and each ball. So, the cost of each bat and each ball, let us take it as x and y. So, from the data given, we can form the equations to be 7x plus 6y equal to 3800 and 3x plus 5y equal to 1750, right? 7 bats and 6 balls equal to 3800 and 3 bats and 5 balls equal to 1750. Now we can take any one equation. Let me take second equation. If I rewrite it, we will get x equal to 1750 minus 5y whole divided by 3. If you substitute this in the first equation, you will get 7 into 1750 minus 5y by 3 plus 6y equal to 3800. So if you simplify this, you will get the values to be 12250 minus 35y whole divided by 3 plus 6y, or you can take LCM so that you will get plus 18y whole divided by 3 equal to 3800. Again, if you cross multiply this and if you simplify, you will get the answer to be minus 17y equal to, if you multiply this, you will get minus 12250. Minus 17y equal to, if you calculate this, you will get minus 850. So this value divided by 17 will give you the answer as 50. So the value of x is 50, and if you substitute this in the third equation, you will get x equal to 1750 minus 5y, that is 250 by whole divided by 3. Clear? So if you simplify this, you will get 1500 divided by 3, which is equal to 500. Clear? So x value is 500 and y value is 50. So thus coach has purchased bats and ball for the cost 550. Clear? Fourth one, the taxi charges in a city consist of a fixed charge together with a charge for the distance covered. For a distance of 10 km, the charge paid is 105 rupees, and for a journey of 15 km, the charge paid is 155 rupees. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 km? So now we have to identify the charge they are fixing for 1 kilometer. Clear? But what they have given is the charge paid for 10 kilometers and 15 kilometers. So we have to find the charge for 1 kilometer, and also we have to find how much a person should pay for traveling a 25 kilometer. Clear? So we can form the equation from the given data. So let us take x and y denotes the fixed charge and the charge in terms of kilometers. Okay, so x denotes the fixed charge in rupees. Okay, in rupees, and y denotes the charge per kilometer. Fine. So what they have given is, if they travel a distance of 10 kilometers, the charge they have to pay is 105, and for a journey of 15 kilometers, the charge they have to pay is 155 kilometers. So the equation what we will obtain will be x plus 10y equal to 105, and similarly x plus 15y equal to 155, right? So now we have to solve these two equations and we have to find the value of x and y. So let me rewrite the first equation and I'll get 105 minus 10y. If you substitute this in the second equation, you will get 105 minus 10y plus 15y. So plus 5y equal to 155. So 5y equal to 155 minus 105 will be equal to 50. So this gives y equal to 10. So by substituting this in the third equation, you will get x equal to 105 minus 100, that is 5. So x equal to 5 and y equal to 10. Clear? So the fixed charge is 5 and the charge per kilometer is 10. Okay, so you have to understand that if you want to travel, you have to pay this fixed charge 5 rupees, and for each kilometer the charge will be keep on increasing. Okay, so that value will be 10. So fixed charge will be 5 and each kilometer you have to pay 10 rupees. Clear? And what they are asking is, if they travel for 25 kilometers, what will be the charge? So the fixed charge will be obviously 5 plus 25 kilometers they are traveling. So 25 into y value is 10. So the charge, total charge will be 5 plus 250, which is equal to 255. So 255 rupees a person has to pay to have a journey of 25 kilometers. Clear? Fifth one, a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and denominator, it becomes 5 by 6. Find the fraction. So clearly they have given it is a fraction. So for a fraction we need to know the numerator and denominator. So the fraction what we need to find is x by y. So if we add 2 to the numerator and denominator, it will become 9 by 11. And if we add 3 to the numerator and denominator, it will become 5 by 6. So if you simplify them, you will get 11x plus 22 equal to 9y plus 18. So 11x minus 9y plus 4 equal to 0. So let us take this as equation 1. 6x plus 18 equal to 5y plus 15. So 6x minus 5y plus 3 equal to 0. This is the second one. So now if we simplify both the equations, you will get the value of x and y. So by rearranging the second equation, I will get x equal to 5y minus 3 by 6, and substituting this in the first equation, I will get 55y minus 33 by 6 minus 9y plus 4 equal to 0. Fine. So if you take LCM, you will get 55y minus 33 minus 54y, which is equal to minus 24. So y equal to 33 minus 24. So you will get the answer to be 9. So if you substitute this in the third equation, you will get the y value, x value to be 9 5s are 45 minus 3 by 6. So this is equal to 42 by 6 is equal to 7. So the x value is 7 and y value equal to 9. Right? So the required fraction is 7 by 9. Clear? And the last problem in this exercise, 5 years hence the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? We have seen a similar problem in the example. Now we have to solve this and we have to find the present ages of Jacob and his son. So let us take the present age of Jacob and son to be x and y. Clear? So Jacob's age is x and for his son the age to be y. And what is the relation they have given? 5 years hence, the age of Jacob will be 3 times that of his son. So after 5 years, that is x plus 5 will be 3 times. The age of his son after 5 years will be 5 plus y, right? And the second condition is 5 years ago, Jacob's age was 7 times that of his son. So x minus 5 equal to 7 times y minus 5. So if you simplify this, you will get x minus 3y equal to 15 minus 5 is 10. Similarly, x minus 7y minus 35 plus 5 will be minus 30. Clear? So now if you simplify these two equations, you will get the answer. By method of substitution, I am going to write the first equation as x equal to 10 plus 3y, and if I substitute in the second equation, I will get 10 plus 3y minus 7y will become minus 4y equal to minus 30. So 4y equal to 10 plus 30 is 40. So I am getting y to be 40. So if I substitute in the third equation, I will get x to be 10 plus 3 into 40. That is thus y equal to 10. So the age of son is 10. If you substitute that in the third equation, you will get x equal to 10 plus 30 is 40. So the age of Jacob is 40 at present and his son age is 10 years. Fine. The next one is elimination method, which is one of the algebraic methods used to solve system of equations or pair of linear equations. Similar to that of substitution method, here also we try to eliminate one variable, but this method is more convenient to that of substitution method. So let us discuss this with the following examples. Example 8, the ratio of incomes of two persons is 9:7 and the ratios of their expenditures is 4:3. If each of them manages to save 2000 rupees per month, find their monthly incomes. So they have given the ratio between the incomes and expenditures of two persons, and they have mentioned each of them save 2000 rupees per month, and they are asking us to find their monthly incomes. Since the ratios were given, we have to consider the incomes of two persons as 9x and 7x and their expenditures as 4y and 3y. Clear? Now we have to form equations, pair of linear equations from the given data that they are saving 2000 rupees per month. So we have to form the equation such that the difference between the income and the expenditure equal to 2000. So for the first one, 9x is the income and 4y is the expenditure. So 9x minus 4y equal to 2000, and for the second person, 7x is the income and 3y is the expenditure. So 7x minus 3y equal to 2000. Now we have obtained pair of linear equations. Now we have to solve this. We can also solve this by substitution method by rewriting any one of the equations by taking one variable in the left hand side and representing that variable by another variable in the second equation, and we can simplify it, that we have already discussed. But now using elimination method, we try to eliminate one variable by multiplying one or both the equations by appropriate constants so that we can eliminate any one variable. Clear? So here they are multiplying the first equation by 3 and the second equation by 4. So the equations 1 and 2 now get changed as 27x minus 12y equal to 6000 and 28x minus 12y equal to 8000. Now we need to subtract the first equation from the second equation so that we will be resulted with the value of x as 2000. Since the variable y got eliminated, we are resulted with the value of x. Now we have to substitute this x value in the third equation, or the equation number 1 or 2 you can substitute, and we will be resulted with the value of y as 4000. So thus we have determined the values of the unknowns x and y by eliminating one variable. So this elimination could be done by appropriately multiplying the equations by the constants. Clear? So this is known to be elimination method. Clear? So now we have determined the x and y value. We have to find the monthly income. So monthly incomes of the two person we have taken as 9x and 7x. So we have to multiply the x and y values, and we are resulted with the monthly incomes of the persons to be 18,000 and 14,000 respectively. Clear? And we can also cross verify the answer. So if you check the ratios between their incomes, it should be 9:7. Similarly, their expenditure, everything will get satisfied. Clear? And here they have given the remarks. This method is known to be elimination method because we eliminate one variable first to get the linear equation in one variable, and we try to find the value of that one variable. From that we can find the value of the other variable. And we have also discussed the idea of substitution and graphical method. So if you take a problem and if you solve that problem with all three methods, you can find this method is more convenient to that of the remaining two methods. So here they have given the steps involved in elimination method. First we have to multiply both the equations by some suitable non-zero constants to make the coefficients of one variable. We can either choose x or y. So, and we have to convert their coefficients to be numerically equal. Sometimes it would be enough to multiply only one variable, or one equation by the constant. So it depends upon the equations what given to us. Next, step 2. We have to add or subtract one equation from the other equation so that one variable will get eliminated, and now we will be resulted with only one equation in one variable. Now we have to move on to the step 3, and here they have given two important points. If in step 2 we obtain a true statement involving no variables, then the original pair of equations has infinitely many solutions. If in step 2 we obtain a false statement involving no variable, then the original pair of equations has no solution, that is, it is inconsistent. So already we have discussed this idea in the substitution method, that when we resulted with a when we try to eliminate one variable, we should be resulted with a linear equation with one variable. Some case we will not be resulted with that. We will be resulted with a statement which can be either true or false. So if it is true, we will have infinitely many solutions. If it is false, it will be resulted with no solution. Okay, fine. Now let us assume that if we get an equation in one variable, then we have to move on to the step 3, where we try to solve that equation in one variable. It can be either in x or y, doesn't matter, so that we will get the value of that variable. Now we have to substitute this value in, that is the variable value, in the other equation which is given in the question, and thus we will be resulted with the value of the second variable. Clear? Next, example 9. Use elimination method to find all possible solutions of the following pair of linear equations. In this question they have mentioned find all possible solutions. So why they have mentioned this term all possible solutions? Sometimes we may be resulted with infinitely many solutions. So we don't know whether we will be resulted with unique or infinitely many. Sometimes we can also result with no solution. So they have used the term all possible solutions, right? So now we have a pair of linear equations with two unknowns x and y. When we observe the two equations, we can see the coefficients of x and y are such that if you multiply the first equation by 2, you will be resulted with the second equation, but still the right hand side values are not equal. So by just observing the system of equations itself, we can come to the conclusion by calculating the ratio between the coefficients of the unknowns and the ratio between the constants. We can conclude that this system will have no solution. Anyhow, we'll proceed with the method of elimination. So first we try to multiply the first equation by 2, so that we will be resulted with 4x plus 6y equal to 16, and the second equation we are not going to do anything, or simply we can just multiply it by 1. Now if we try to subtract the first equation from the second equation or second equation from the first equation, you will be resulted with the statement 0 equal to 9. This statement is false. So what we conclude is the given pair of linear equations will have no solution. Moving on to the example 10. The sum of a 2-digit number and the number obtained by reversing the digits is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? So here they have given that the sum of 2-digit number and the number obtained by reversing the digits is 66. So we have to consider a 2-digit number. We don't know what is the number, but we have to consider a 2-digit number, and if we add the 2-digit number with its reverse, then we will get the value to be 66. And they have also mentioned that if the digits of the number differ by 2, so the difference between the two digits in that 2-digit number is given to be 2. Now we have to find the number, and they have also asked us to find how many such numbers could be formed by satisfying all the above conditions. Clear? So we have a 2-digit number. So we will have one digit in the units place and the other digit in the tens place. So we will consider the 2 digits to be x and y. Fine. So if you multiply x by 10 and if you add with y, you will get the expanded form of that number. For example, here they have mentioned 56. 56 can be obtained by multiplying the x value, that is 5 by 10, and if you add with 6, you will get that number 56. Clear? Fine. Now let us take that number to be 10x plus y. Here they have mentioned that we have to add this number with its reverse. So reverse digit will be 10y plus x. Clear? So if we add these two numbers, 10x plus y and 10y plus x, they have given the sum to be 66. So if you simplify this, you will be resulted with x plus y equal to 6. And also they have mentioned that the difference between the two digits is 2. That is x minus y equal to 2. They have mentioned only difference. So it can be x minus y or y minus x. So if we take x minus y equal to 2, then if we solve the two equations 1 and 2, the first equation and the second equation x minus y equal to 2, by elimination method we can simply add the two equations, so the variable y will get cancelled and we will be resulted with 2x equal to 8, so x equal to 4. So from this we can find the y value to be 2. So the expected digit is 42. If we consider the second case y minus x equal to 2, then if we solve the first equation and third equation by elimination method, we will be resulted with the values of x and y to be 2 and 4. So in this case the number will be 24. Its reverse will be 42. Okay. So since we have two cases for the second condition, we are resulted with two such numbers which satisfies the conditions given in the question. So the numbers are 42 and 24. Clear? We can also verify the conditions given in the questions. The two numbers will definitely get satisfied. Moving on to the exercise 3.3. Solve the following pair of linear equations by the elimination method and the substitution method. So we have to solve the following pair of equations by both the methods. Yeah. So first let us solve by elimination method and then we will solve by substitution method. So exercise 3.3. First question, x plus y equal to 5 and 2x minus 3y equal to 4. Let us take these to be 1 and 2. If we apply the elimination method, then we have to eliminate any one variable. It can be either x or y. Now let me fix the variable to be x. So in order to eliminate x, I want to make the coefficients in both the equations of x to be same. So I am going to multiply the first equation by 2. So I will be resulted with 2x plus 2y equal to 10. And the second equation I am just going to take it as such. So I will get 2x minus 3y equal to 4. If you subtract the second equation from the first equation, the variable x will get eliminated and we will be resulted with 5y equal to 6. So y equal to 6 by 5. If you substitute this y value in the first equation, you will get x equal to 5 minus 6 by 5, which is equal to 19 by 5. Thus, we have obtained the values of the unknowns x and y to be 19 by 5 and 6 by 5. Now we are going to solve the same problem by substitution method. Okay. This is elimination method. So in the substitution method, we will rewrite any one equation by taking one variable on the left hand side and the other variable on the right hand side. So let me take the first equation. From this, I will obtain the value of x to be 5 minus y. So if I substitute this third equation in the second equation, I will get 10 minus 2y minus 3y equal to 4. So minus 5y equal to minus 6. So y equal to 6 by 5. So if you substitute this y value in the equation 3, I will get x equal to 5 minus 6 by 5 is nothing but 9 by 5. So in both the methods, we will get the same answer. Clear? Next, second problem. 3x plus 4y equal to 10 is the first equation. 2x minus 2y equal to 2 is the second equation. So now we try to eliminate the variable 2. So you can choose the variable accordingly, so that if you simply multiply one equation by the constant, you can eliminate that. So you can prefer to eliminate that variable. But in some case we cannot do so. In that case, you can choose which constant is small, that one you can choose. Clear? So now I am going to eliminate this variable y. So I am going to take the first equation as such. So 3x plus 4y equal to 10. And the second equation I am going to multiply it with 2. So you will get 4x minus 4y equal to 4. So if you add both the equations, you will be resulted with 7x equal to 14. So x equal to 2. So if you substitute this in the first equation or second equation, let me substitute in the second equation, I will get 2y equal to 4 minus 2, y equal to 1. Therefore, the values of x and y are 2 and 1. Now we have to solve the same problem by substitution method. Okay, so now I am going to rewrite the second equation. So the second equation can be rewritten as x equal to 2 minus 2 plus 2y by 2. So x equal to 1 plus y. Clear? If we substitute this x value in the first equation, we will get, so let me take this as equation number 3. So if you substitute in the first equation, you will get 3 plus 3y plus 4y, that is 7y equal to 10. So I will get 7y equal to 7, so y equal to 1. If you substitute this y value in the third equation, we will get x equal to 1 plus 1 will be 2. So x equal to 2 and y equal to 1 is the required answer. And what we have obtained in the elimination method. Now let us solve problem number 3 by elimination method. 3x minus 5y minus 4 equal to 0. 9x equal to 2y plus 7 is the second equation. Now, by elimination method, we have to eliminate any one variable. Since the coefficients of x and y are multiples of 3, we can try to eliminate the variable x first. So I am going to multiply the first equation by 3. We will get 9x minus 15y equal to 12. And the second equation I am going to multiply it by 1. So 9x minus 2y equal to 7. So if you subtract the second equation from the first one, x will get eliminated and you will get the y coefficient to be minus 13 and the constant value to be 5. So the value of y equal to minus 5 by 13. So if you substitute this in the first or second equation, you will get the x value. So let me substitute in the first equation. We will get 3x equal to 4 plus 5y. So if you substitute y, you will get minus 25 by 13, which is equal to 52 minus 25 is 27 by 13. If I again rewrite this, I will get x equal to 9 by 13. Okay. So this is the x value and the y value is minus 5 by 13. So now let us do by substitution method and let us check whether we are getting the same values for x and y. Fine. So for substitution method, I have to rewrite any one equation. Since the second equation is already in the form, let me take the second equation, and if you rewrite that, you will get x equal to 2y plus 7 whole divided by 9. Fine. So if I substitute this in the first equation, I will get 3 into this x value. Since we have 9 in the denominator, we can cancel that. So we will get 2y plus 7 by 3 minus 5y minus 4 equal to 0. Right? So if we take LCM, we will get 2 minus 15y minus 13y plus 7 minus 12 whole divided by 3 equal to 0. So we will get minus 13y equal to plus 5. So y equal to minus 5 by 13. Yeah. And if you substitute this y value in the third equation, we will get x equal to 2y plus 7 by 9. So 2y is minus 10 by 13 plus 7 whole divided by 9. So if you take LCM, you will get minus 10 plus 91. So 81 by 13 into 9. So if you cancel this, you will get the value of x to be 9 by 13. So we have obtained the x and y values to be same as that we obtained in the elimination method. Yeah. Now moving on to the fourth problem. X by 2 plus 2y by 3 equal to minus 1. X minus y by 3 equal to 3. So first let us rewrite the first equation so that the coefficient will become an integer. Okay. So let us take the LCM for the first equation. So this equation will become 3x plus 4y equal to minus 6. Okay. So this is the third equation. Now let us multiply the second equation by 3. So 3x minus y equal to 9. So this is the fourth equation. Now if you subtract the fourth equation from the third equation, you will get the x variable to be eliminated and you will get 5y equal to minus 15. So y equal to minus 3. And if you substitute this in the second equation, you will get x equal to 3. So this will become plus y by 3. So minus 3 by 3 will become 1. So x equal to 2 and y equal to minus 3 is the answer what we have obtained. Now let us check this by substitution method. Okay. So for that I have to rewrite any one equation, either 1 or 2. So let me take the second equation. So if I rewrite that, I will get x equal to 3 plus y by 3, right? So if I substitute, let me take this as 3 star. If I substitute this in the first equation, I will get 3 plus y by 3 whole divided by 2 plus 2y by 3 equal to minus 1. If you take LCM, you will get 9 plus y by 6 plus 2y by 3 equal to minus 1. If you again take LCM, you will get 6, 9 plus y plus this one I have to multiply by 2. I will get 4y equal to minus 1. So 5y equal to minus 6 minus 9. So this will give you the y value to be minus 15 by 5, that is minus 3. So y equal to minus 3. So if you substitute this in the equation 3 star, you will get x equal to 3 minus 3 by 3, that is 3 minus 1 equal to 2. So thus we have obtained the values of x and y to be 2 and minus 3, similar to that of the elimination method. Fine. Next, problem number 2. Form the pair of linear equations in the following problems and find their solutions if they exist by the elimination method. So first one is, if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes 1 by 2 if we only add 1 to the denominator. What is the fraction? So they have asked us to find the fraction and they have not given the numbers. So let us randomly take the fraction to be x by y. And what they have given is, if we add 1 to the numerator and subtract 1 from the denominator, the fraction reduces to 1. So let us form the equations first and then let us solve this by elimination method. So let x by y be the fraction required. Clear? And if we add 1 to the numerator and subtract 1 from the denominator, this fraction will become 1. Clear? And it becomes 1 by 2 if we only add 1 to the denominator. So if we add 1 to the denominator, this will become 1 by 2. Okay. Now we have to identify what is the fraction. Let us take this to be the first equation and this the second equation. Now let us rewrite the two equations. So first one I am going to rewrite this. So x plus 1 equal to y minus 1. So this will become x minus y equal to minus 2. So let us name it as equation number 3. The second equation, if you rewrite, you will get 2x equal to y plus 1. So this will become 2x minus y equal to 1. So this is the fourth equation. Now let us solve the equation 3 and 4 by elimination method. Subtract the fourth equation from the third equation. So we will get minus x equal to minus 3. Therefore, x equal to 3. Now, if you substitute this x value in the third equation, we will get y equal to 3 plus 2 equal to 5. So, y equal to 5. Fine. So, we have determined the fraction to be 3 by 5. If you check the conditions, that is by adding 1 to the numerator, it will become 4, and subtracting 1 from the denominator, it will become 4. So 4 by 4 equal to 1. Again, 3 divided by 5 plus 1 is 6. So 3 by 6 will become 1 by 2. So thus the solution what we have obtained satisfies the given condition. Problem number 2. 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? So here they have given the relation between the ages of Nuri and Sonu. So 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. And they are asking us to find the current ages of Nuri and Sonu. So let us take the current ages of them to be x and y. So the current age of Nuri to be x and Sonu to be y years. We have to form the equations from the given conditions. So 5 years ago, Nuri's age will be x minus 5 and Sonu's will be y minus 5. So what they have given is 5 years ago, Nuri was thrice as old as Sonu. So x minus 5 equal to 3 times of y minus 5. Okay. So this is the first equation. And the second condition is 10 years later, Nuri will be twice as old as Sonu. So 10 years later, x plus 10 equal to 2 times of y plus 10. So this is the second condition. Now we have to find the x and y value. So by rearranging the equation number 1 and 2, we will get x minus 3y equal to minus 15 plus 5. So minus 10. Clear? So this is the third equation. Similarly, rearranging the second one, we will get x minus 2y equal to 20 minus 10 is plus 10. So this is the fourth equation. Subtract the fourth equation from the third equation. We will get the variable x to be eliminated and we will get minus y equal to minus 20. So y equal to 20. Fine. So if you substitute this y value in the third equation, we will get x equal to minus 10 plus 60, which is equal to 50. So x equal to 50. So we have determined the ages of Nuri and Sonu to be 50 and 20. Now let us check the conditions. So 5 years ago, the age will be 45 and 15. So 45 is thrice that of 15. And 10 years later, the ages will be 60 and 30. So 60 is twice that of 30. So thus we have verified the given conditions. Problem number 3. The sum of the digits of a 2-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. So they have given a 2-digit number. So already we have discussed a similar problem in the example. So let us take the 2-digit numbers to be x and y. The 2 digits to be x and y, such that y will be in the units place and x will be in the tens place, right? So that number what we require is 10x plus y. Fine, this is the 2-digit number what we need to find. And what are the conditions they have given is sum of the digits of the 2-digit number is 9. So they have given 10x. So they have given x plus y equal to 9. Also 9 times this number is twice the number obtained by reversing the order of the digits. So 9 times this number. So 9 times of 10x plus y will be equal to twice the number obtained by reversing the digits. So 10y plus x. Fine. So thus we have obtained 2 equations. Now we have to apply the elimination method and solve the equations, right? So the first equation is very simple. So now we have to rearrange the second one. So we will get 90x plus 9y equal to 20y plus 2x. So if you rearrange this, you will get 88x equal to 11y. So 88x minus 11y equal to 0 is the rewritten form of equation number 2. Now if we multiply the first equation by 11, we will get 11x plus 11y equal to 99, and if you take the third equation, we will get 88x plus minus 11y equal to 0. So if you add these two equations, you will get 99x equal to 99. So x equal to 1. So if you substitute this in the third equation, you will get 11y equal to 88. So y equal to 8. So we have determined the values of x and y to be 1 and 8. Therefore, the number, the 2-digit number what we require is 18, 18. Yeah. Next, problem number 4. Meena went to a bank to withdraw 2000 rupees. She asked the cashier to give her 50 rupees and 100 rupees notes only. Meena got 25 notes in all. Find how many notes of 50 rupees and 100 rupees she received. So now she wants to withdraw 2000 rupees from the bank. So she specifically insists the cashiers to give the cash in 50 and 100 rupee notes. Okay. So in total she is getting 25 notes. So they are asking us to find how many notes will be there in 50 rupees and 100 rupees separately. Fine. So now let us form the equations corresponding to the above conditions. So in total she will be withdrawing 2000 rupees. So number of notes in 50s and 100s let us take to be x and y. So number of 50 rupees note will be x, and similarly number of 100 rupee notes will be y. So the first condition what they have given is the total sum is 2000, right? So 50x plus 100y equal to 2000. Fine. And the second condition is the total number of notes what she obtained is 25. So x plus y equal to 25. Right? So this is the second equation. If you divide the first equation by 50, you will get x plus 2y equal to 40. Fine. So let us take this as equation number 4. Now if you subtract the second equation from the third equation, you will get y equal to 15. Fine. If you substitute this y value in the second equation, you will get x equal to 25 minus 15 equal to 10. So thus we have determined the x and y value. So the number of 50 rupees notes will be 10 and 100 rupees notes will be 15. Right? You can also substitute the x and y values in the equations and verify, and you can also check the conditions got satisfied or not. Problem number 5. A lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid 27 rupees for a book kept for 7 days, while Susie paid 21 rupees for the book she kept for 5 days. Find the fixed charge and the charge for each extra day. So they have not mentioned how much they are charging, but for the first 3 days they are having a fixed charge. From the 4th day they are having additional charge. Okay, so Sarita paid 27 rupees for one book and she kept it for 7 days, whereas Sushi paid 21 rupees for one book but for 5 days. Now let us form the equations corresponding to the above problem. For Sarita, first 3 days she will be having only the fixed charge. So total she has kept the book for 7 days. So 4, 5, 6, 7 for remaining 4 days she will be having additional charge. So let us take the fixed charge to be x rupees and additional charge to be rupees y. Okay, so for Sarita, x plus 4y equal to 27, right? In the case of Susie, she kept the book for 5 days, so she has to pay the additional charge for 2 days. So the equation corresponding to the second case is x plus 2y equal to 21. So now we have to apply elimination method. So simply you subtract the second equation from the first equation. So x will get eliminated. You will get 2y equal to 6. So y equal to 3. If you substitute y in the second equation, you will get x equal to 21 minus 6 equal to 15. Fine. So we have determined the x value to be 15 and y value to be 3. Clear? So the fixed charge is 15 rupees and for each day the additional charge is 3 rupees. Fine. So the last section is summary. So here they have consolidated all the ideas whatever we have discussed in this chapter. So let us recollect them. The first point is, for a pair of linear equations in 2 variables, we can solve them by 2 important methods, graphical method and the second one is algebraic method. In the graphical method, first we need to draw the graph of the linear equations in the given system by representing them in the straight lines. For that we have to identifying the points which lie on the straight lines, right, by taking either x equal to 0 or y equal to 0. And from the above three cases, we can come to the conclusion about the nature of the solution. If the lines intersect at a single point, then we will have unique solution, and the pair of equations is considered to be consistent. If the lines coincide, which means one line will lie on the other line, then they will have infinitely many solutions, and in this case the pair of equations are said to be dependent, and still they remains to be consistent. The third case is if the lines are parallel, that is there will be no intersection point, then we will have no solution to the pair of equations, and in this case they are considered to be inconsistent. The third point is algebraic methods. Compared to that of a graphical method, we can identify the solution easily using the algebraic methods. So here we have two methods, substitution method and elimination method. Both the methods are simple, but comparatively elimination method is more convenient. So when we are given a pair of linear equations, now we can verify the ratio between the coefficients of x and y and the ratio between the constants, and from the below three cases we can come to the conclusion about the consistency of the pair of linear equations. If the ratios a1 by a2 is not equal to b1 by b2, then we will have the pair of equations to be consistent. If both the ratios are equal but they are not equal to c1 by c2, then the pair will be inconsistent. If all the ratios are equal, then the pair of linear equations known to be dependent and is consistent. Fifth point, there are several situations which can be mathematically represented by two equations that are not linear to start with, but we alter them so that they are reduced to a pair of linear equations. So in some cases we can convert the non-linear equations into linear, and we try to solve them by the above mentioned methods. So with this we have completed chapter 3. If you have any doubts, you can comment in the comment section, and if you like the video, please click the like button and share the video to your friends. Please subscribe to the channel. Thank you.